In this video, we will look at a few examples to practice working with rotation symmetry. In example A, it says, determine if the figure below has rotational symmetry. Find the angle and how many times it can be rotated. So, if we're thinking about rotating it about its center, this is a regular pentagon, or at least we should assume that it is. It has 4 sides, and if it's going to have any sort of symmetry, those sides have to be congruent. So we'll assume that it's a regular pentagon, and because it's a regular and because it's a pentagon with 5 sides, what we're looking for is how many degrees would it take so that each point sort of moves to the next point location. So if you think about it, that would be moving the pentagon 1/5 of the way around a full circle. Because if we wanted to go back to where everything started, that would be 360 degrees. So if we do 360 divided by 5, that will tell us how many degrees to rotate in order to get that 1/5 of the way around the circle. 360 divided by 5 is 72 degrees, which means that any multiple of 72 degrees, if you rotate the pentagon that many degrees, it will look exactly the same. So 72 degrees, 144 degrees, and so on. So it does have rotation symmetry, and it can be rotated 4 times to show the rotation symmetry. The 5th time, you would have rotated 360 degrees, which doesn't count for rotation symmetry. So it can be rotated 4 times to show that rotation symmetry, and after that, it doesn't really count as rotation symmetry anymore. The smallest angle that you can rotate it is 72 degrees. In example B, it says, determine if the figure below has rotational symmetry. Find the angle and how many times it can be rotated. So in this case, this letter N, if we think about its sort of center point right there, if we rotated it just a quarter turn, 90 degrees, it would sort of be on its side and look instead like a Z, like this. But if we rotated it 180 degrees, it would be back to looking exactly the same again. So while 90 degrees doesn't work, 180 degrees does work, and you can rotate it 1 time, just that 180 degree rotation, and have it look the same. So the angle of rotational symmetry is 180 degrees, and it can be rotated just 1 time to exhibit that rotational symmetry. Remember, this thing that I drew here was the 90-degree rotation, which was sort of halfway to making it look right. In example C, it says, determine if the figure below has rotational symmetry. Again, find the angle and how many times it can be rotated. So about this center point, what I notice is that this little checkerboard here has basically 4 congruent quadrants. And it's a checkerboard, but it's also a square behind that. So the minimum number of degrees you could rotate it is 90, because that would cause each point to move to the next point location. And because all 4 of these little quadrants look the same, it will match up exactly inside as well, beyond just the outside looking square. So 90 degrees is the minimum number of times, or the minimum degrees you can rotate it. You could also rotate it 180 degrees or 270 degrees, which means it can be rotated 3 times total to show that rotational symmetry. And the smallest angle of rotation is 90 degrees.